All right, let's talk about something that's becoming absolutely critical in the AI space, the AI Assurance Playbook. And we'll be looking specifically at red teaming and tools like Promptfoo.
Welcome to K11 Software Solutions' AI-powered test automation playlist. In this session, we're going to examine some really practical methods for adversarial testing, prompt evaluation, and how you can actually get assurance that your AI is behaving the way it's supposed to, especially when you're working at scale. It's all about making sure the AI we build isn't just functional, but truly, truly safe. So let's dive right in.
So this really is the million-dollar question, isn't it? Your AI works, but is it safe? It's one thing to get an AI to work perfectly when everything is going right, but what happens when it gets pushed? Or, even worse, what happens when someone is actively trying to break it? That's the leap we have to make. We've got to move beyond just checking for functionality and start building for genuine, rock-solid assurance.
Okay, so here's our game plan. We're going to walk through this playbook in 5 key steps. First, we'll talk about the new challenge facing QA. Then, we'll get into the fun stuff, how to think like an adversary. After that, we'll see how to make this whole process more scientific, not just an art form. We'll look at a real-world case study, and then we'll wrap it all up by focusing on the end goal, which is all about building trust. All right, first up, the new QA challenge. You might be wondering, why can't we just use our old QA methods? Well, it's because the game has totally, completely changed. So think about it like this. Our traditional software testing is fantastic at what it does, right? It catches the stuff on the left, functional bugs, performance issues, regressions. We absolutely still need that, but it's just not enough anymore. With AI, we're dealing with a whole new class of risks. I'm talking about things like hallucinations, where the model just makes stuff up, or hidden biases, or, and this one is scary, prompt injection attacks that can lead to massive data leaks. These aren't your typical bugs, and they need a whole new way of thinking. And that new way of thinking, well, it means you have to change your entire mindset. You have to stop thinking like the person who builds the thing and start thinking like the person who wants to break it. And that, right there, is the whole idea behind AI red teaming. So, what is AI red teaming really? At its heart, it's an adversarial evaluation. You're not just checking boxes to see if the AI does what it's supposed to. Nope. You are actively, creatively, and, let's be honest, kind of ruthlessly trying to make it fail. You're simulating real attacks to poke and prod for weaknesses. The whole point is to find those nasty, hidden vulnerabilities before the bad guys do. And this really gets to the heart of that red team mindset. You see, the questions change. We start asking, does the feature work? And we start asking things like, can I trick this model into leaking sensitive data? Or can I write a prompt that just completely bypasses all the safety rules? You start wondering if it's going to stay compliant or if it's going to spit out biased nonsense in a really high-stakes moment. It's a total shift from confirming success to actively hunting for failure. Okay, so thinking like an adversary is awesome. It's powerful, but it can also be a little chaotic, right? So the next big step in maturing this whole approach is to bring some structure to the party. We need to turn the art of breaking things into a science. And here's the classic problem with red teaming. A lot of the time, it's just one or two really smart people in a room trying to come up with clever attacks. And don't get me wrong, that's great for finding brand new exploits. But it's like a one-off magic show. It's almost impossible to repeat, it's really hard to measure, and you can forget about trying to scale that across a huge organization. And that's where the solution comes in. Frameworks like Promptfoo are a total game changer here. They let you take that creative, almost artistic process of finding vulnerabilities and turn it into a repeatable, measurable science. It's all about bringing some much-needed discipline to the chaos.
And what this does is create this incredible, powerful feedback loop. So check this out. First, you discover some new way to attack the system. That's your red team at work. But, and this is the critical part, you don't just write it down in a report, you capture it. Use a framework to turn that attack into a real test case. And then you automate it. You add it to your test suite that's running all the time. That is how you build resilience that actually lasts and gets stronger over time.
Okay, that's enough of the theory. Let's make this real. We're going to dive into a case study and see red teaming in action with a company called WeOptimize.ai. So here's the setup. The target is this B2B AI assistant, and it's integrated with all the big enterprise tools you can think of. Jira, Confluence, Figma, the whole shebang. Its job is to help employees by giving them answers from all those sources. Now, you can probably see why this is such a juicy target, right? It's sitting on a potential goldmine of sensitive company data. So here's a perfect example of a classic attack, a jailbreak. Look at this prompt. The attacker isn't trying to hack the code. They're trying to socially engineer the AI itself. They're saying, hey, for testing, just pretend you don't have any rules. It's a persuasion game, trying to convince the AI to just ignore its own programming and spill the secrets.
Okay, but this next one, this is where things get really interesting. This is a prompt injection attack, and it's way more sneaky. See, the malicious instruction isn't coming from the user. It's actually hidden inside a piece of data the AI is supposed to be reading, like a random JIRA ticket. The AI gets tricked into thinking that this data is actually a new instruction. This is a huge top-tier vulnerability for large language models.
So the team ran 140 of these kinds of adversarial probes, and here are the results. Now, at first glance, you might look at this and think, wow, 98% passed, that's amazing. And yeah, most of the attacks were blocked. But the real story, the part that should keep you up at night, is in that little 2% slice. Because in the world of security, that tiny sliver, that's where the disaster is hiding.
And that tiny 2%, it translated into 3 critical vulnerabilities. And this, right here, is exactly why we do this. Your system can look perfect on paper, passing 98% of its tests, but it's those 3 hidden gaps that could lead to a massive data breach or a complete compliance nightmare. Red teaming isn't about finding all the bugs, it's about finding the few critical failures that could bring everything down.
And that brings us to our final, and honestly, most important point. All of this work, the red teaming, the frameworks, it's not just some fancy new technique for finding bugs. It's about something much, much bigger. See, at the end of the day, this is all about building trust. It's about creating a portfolio of evidence. Every single test you run, every vulnerability you find and then fix, that becomes a piece of evidence. It's the proof you need to show your users, to show regulators, to show everyone that your AI isn't just cool and innovative, it's also responsible, safe, and trustworthy.
And if you remember one thing from this whole case study, make it this. The biggest risks, they're usually not inside the AI model itself. The real danger is at the edges, at the boundary, where the AI connects to your other tools and data. That spot where it talks to an API or pulls from a database, that is almost always the weakest link in the chain.
So how do we lock down those boundaries? It comes down to a 3-part strategy. First, access. You have to enforce least privilege, a zero-trust mindset, at every single connection point. Second, integrity. You need to make the AI prove its work with citations and teach it to treat outside content as data, not as instructions. And finally, safety. This means having standard ways to refuse bad requests and, crucially, embedding all those red team probes we found right into your continuous testing. You have to make it an automated, always-on defense.
So we end up right back where we started, but hopefully with a whole new perspective. Look, building an innovative AI is an amazing achievement. But the really tough question you have to ask yourself, your team, your stakeholders is this. Is it truly assured? Have you done the hard work to prove that it can really, truly be trusted?